Hi guys. So today I wanted to make a video about what's called the Pythagorean Theorem. And I know that looks like a crazy word that you have probably either not heard before, or when you do hear it, it kind of makes you sick at your stomach because you don't want to think about the horrible times you maybe tried to do this in school. But this is something that does show up on the GED. So it's something that we need to talk about, obviously. And it shows up on the GED by itself, but it also shows up kind of hidden in some other geometry type problems. So I thought that we would talk about it today. So there's a lot of different kinds of triangles in math. But the Pythagorean theorem only applies to what are called right triangles. And so it's a right triangle if it has this perfect little corner right here. And so the picture of the triangle will always have that corner there to show you that, hey, this is a right triangle. It has a right angle or a 90-degree angle inside of it. And so this Pythagorean theorem only works for these kinds of triangles. It only works if it has that perfect corner, if it has that right angle or that 90-degree angle inside of it. So the first thing about the Pythagorean theorem and right triangles is, again, this corner is your 90-degree angle or your right triangle. And these sides over here that I'm writing the A and the B next to, these are what are called the legs of your right triangle. And the reason they're called the legs is because those are the two sides that come together to make that 90-degree angle, to make that perfect corner, that perfect 90-degree corner. And so those are always considered sides A and side B. But this side over here that is straight across from that 90-degree angle, this is what is called side C. Now, sides A and B, they can be interchanged. You can switch those. So, for instance, this one, you could call it B or you could call it A. And same thing over here. But the one that is across from that perfect corner, from that right angle, that is always considered C, no matter what. That one is always C. So, just to recap, A and B can be switched around, but C always has to be the one that's across from that perfect triangle. And so going back to the Pythagorean theorem. So, for one thing, these parts of a right triangle, their parts have different words. So, these sides of the right triangle that make that perfect corner, these are called the legs. And this side over here, that's across from the right triangle, or across from the right angle, this is what's called the hypotenuse. And I know that's a $5 word, as some people would call it, but it's a hypotenuse. And so the legs are interchangeable. It can be leg A, leg B, you can switch those around. But again, this one is always the hypotenuse. The one that's across from that perfect corner is always considered the hypotenuse. And another way that we label these sides of a right triangle is that sometimes we will call the two legs A and B, and then the hypotenuse is always the letter C. So A and B can be switched around, but C always is the hypotenuse. So the side that's across from that right angle, that perfect corner, that is always the letter C. That is always the hypotenuse, no matter what. And the reason it's important that you remember that you remember that C is always the hypotenuse, is because with the Pythagorean theorem, there is this equation that goes a squared plus b squared equals c squared. And so you have to remember that this side over here is always going to be c, or it's not going to work out as a problem. It won't work. So let me give you some examples of this. Let's say that I have my right triangle, and that this side right here is 12. And then the bottom of it is 16. And I have no idea what this side over here, or what the hypotenuse, or side C is. I have no idea. And so I have to figure out what it is. And in math, the way that we figure out what this side is through that Pythagorean theorem, that a squared plus b squared equals c squared. And so remember, it doesn't matter which of these two sides is A and which is B, but this one over here always has to be C. So I'm going to take 12 and put it in for A, and I'm going to put 16 in for B, and we're trying to figure out what C is. So I end up getting 12 squared plus 16 squared equals C squared, and that's what we're going to try to figure out. So the next step that I have to do is to actually square these two numbers and figure out what 12 squared actually is. So remember, squaring something is the exact same thing as just multiplying it by itself. So 12 times 12 gives me 144, plus 16 times 16 gives me 256. And so all that is going to equal c squared. So when I add those together, I get 400. So I get c squared equals 400. But notice, I don't have c by itself. I have c squared. And I don't want to know what c squared is. I want to know what c is. So this is where I get into the math word for it is inverse operations. So I have to figure out what c is all by itself. So I said c squared equaled 400, right? Yes, c squared equals 400. So this little 2 is me saying that, hey, c times itself equals c squared. And so in algebra, if you want to figure out what a letter is by itself, you have to do, the math word for it is called inverse operations. And all that means is that you're just doing the opposite kind of math. So like if you were multiplying, you'd do the opposite and you would divide. If you were adding, you'd do the opposite and you would subtract. So in this case, I'm squaring something. So what's the opposite of squaring something? It is this little symbol called the square root symbol. And all that square root symbol is it is just asking what number times itself gives you that number. So I want to do the opposite of c squared. And so the opposite of squaring something is that square root symbol. So I'm going to get the square root of 400. So what number times itself gives us 400? Well, let's see. Let's put that in our calculator. And so our answer would be 20. So what was the missing side of that triangle? Back a couple pages. Oops, went back too far. 20. Let's try another one together. Let's say that they gave me this right triangle, and they want me to figure out what x is, or what the hypotenuse is. So I have 5 for my side A, and I have 12 for side B. So again, just to remind you, the Pythagorean theorem formula is a squared plus b squared equals c squared. And I said 5 is A, 12 is B, and the number I don't know is going to be C. So where 5 is, or where A is, sorry, I'm going to put my 5. Where B is, I'm going to put my 12. And I don't know what C is. So now I'm going to do the stuff that I know. So if I have my calculator, I would put 5 squared in there. So what's 5 times itself? 25. Plus 12 squared, or 12 times itself, is 144. Equals c squared. So now what I'm going to do, these two numbers, I'm just going to add together like normal. They're on the same side of the equal sign. I'm just going to add them together like normal. So when I add 25 plus 144, I get 169. So it looks like I'm done, but remember, I have to get c by itself, and I don't have a plain c, I have a c squared. So what do I have to do in algebra? I have to do the opposite of squaring, which is the square root. And so when I put the square root of 169 in my calculator, I get 13. So the missing side, of that right triangle is 13. So up until this point, we have been trying to find this side of the triangle. We've been trying to find the hypotenuse. But on the GED, they don't always set it up like that. Sometimes you are going to have to find what is called the leg of the triangle. They'll tell you the hypotenuse, they'll tell you one leg of the triangle, and you have to figure out what the missing leg is. And so that's what we're going to do for this one. Now remember, my formula is a squared plus b squared equals c squared. And c is always that side of the triangle, the hypotenuse, that's across from the perfect corner. And then remember, it doesn't matter which one of these you want to make A or which one you want to make B. So for this case, for this one, I'm going to say that 7 is A. So I'm going to put 7 squared plus B squared equals, and then my C squared is 25, so 25 squared. So just like if I was trying to find side C instead of side B, I'm going to go ahead and square these or multiply them by itself. So what is 7 squared, or 7 times itself? 49. Plus, now I don't know what B squared is, so I'm just going to bring that on down. I'm going to bring my equals down. And then I'm going to figure out what 25 squared is, or 25 times 25. And when I do that, I get 625. So this is where a geometry problem turns into an algebra problem. Now, if you've worked on algebra before, I don't mean to freak you out by using the word algebra, But all algebra is just trying to figure out what a missing letter is. And what I always do, I like to draw a line down my equal sign. Because in algebra, it's like it's a seesaw. I want to get my letters on one side and my numbers on the other side of that equal sign. So I always draw a line just to try to keep myself balanced. So I am going to just go ahead and write this over onto this page. I'm going to draw my line. Okay. So I want my letters to be over here, and I want my numbers to be over here. And so what I have to do, I have to bring this 49 over to be on this side with my 625. And the way that I do that in algebra is I do what's called the inverse operation. And all that is a fancy math word for the opposite. So see how I'm adding here? So if I'm adding 49, I'm going to do the opposite of adding 49. So what's the opposite of adding? Right, subtracting. So I'm going to subtract 49 to make this go away. And in algebra, what you do on this side, you have to do on this side too. So I'm going to subtract 49 from 625. And so when I take 625 and I subtract 49, I get 576. Now the next thing you're going to do is just bring down your equal sign, and then this b squared is just going to slide on down. So now it's basically what we did when we were trying to find c instead of b. I don't have b by itself, I have b squared. So I have to do the opposite of squaring. And what's the opposite of squaring something? That square root symbol. And remember, square root just means what number times itself gives us that number. So I'm going to figure out the square root of 576. And it is 24. So that means when I go back to my triangle, what was that missing side? 24. Very good. Let's say that you get a word problem like this on the GED. So it says, for a circus act, an 18-foot pole is braced with a wire that extends from the top of the pole to a stake in the ground, 80 feet from the base of the pole. How long is the bracing wire? So they want to know how long that bracing wire is, or basically how long this side is. So remember, here's our perfect corner, so that means that that's our hypotenuse, or that is side C. And that means that these two sides are A and B. So we're going to take these numbers and fill them in where A and B go. So A is 18, so 18 squared plus 80 squared equals C squared. So first I'm going to figure out what 18 squared is, and it is 324 plus whatever 80 squared is, which is 6,400. And all that equals C squared. So when I add 6,400 plus 324, I get 6,724 equals C squared. Now, I figured out what C squared is, but remember, I'm not done. I need to figure out what C is all by itself. So I'm going to do the opposite of squaring, which is find the square root. So what's the square root of 6,724? 82. So, how long is that bracing wire? It is 82 feet long. So, this is it for my Pythagorean theorem video. I hope you enjoyed it. I hope that you learned something, that you took something away from this. So look for this in our Google Classroom and on the Pulaski Skills U Facebook page. And if you're watching this, go to our Google Classroom, do the self-check on the Pythagorean theorem, see how you do, and hopefully this will help you as you work on your GED. If you have questions, remember to email us, post comments or questions in the Google Classroom, or on our Facebook page, Pulaski Skills U, and that is U, the letter U. So, have a great day. Again, any questions, feel free to email us, Facebook message us, ask them in the Google Classroom. We are just working on new and different ways to serve you from home. Have a great one.